So we're going to do number 48 on page 50. The question is, a ball thrown vertically upward is caught by the thrower after 2 seconds. Part A, find the initial velocity of the ball. And part B, find the maximum height the ball reaches. So we'll begin by drawing a picture. So it's going to be a downward parabola. And we'll start writing the knowns. Time is 2.00 seconds. The acceleration due to gravity is going to be negative 9.8 meters per second squared, because we're going to assume that upward is positive. Then our initial velocity is unknown. We're trying to find that. Our final velocity is 0 because it reaches the top, and then the final velocity will be 0. And then our delta y is also 0 because it reaches back down to the thrower's hand, so there is no change in y in the end. The equation we'll use is delta y equals initial velocity times time plus 1/2 acceleration times time squared. We know that delta y is 0, which will make it easier for us to isolate the variable that we want, which is initial velocity. And then we'll try to isolate the initial velocity, which is negative 1/2 a times squared over t. And then the t's just cancel out. And then we'll try plugging in the acceleration in time, which is negative 9.8 meters per second squared times 2.00 seconds. So the seconds cancel out, the 2 cancels out, the negative cancels out, and all we're left is 9.8 meters per second for our initial velocity. Part B, we're trying to find the maximum height, which is this right here. That is also our delta y. Our initial velocity, as we found, was 9.8 meters per second. Our final velocity is again 0. Our delta y is our unknown, and our acceleration is again negative 9.8 meters per second squared. The equation we'll be using here will be final velocity squared equals initial velocity squared plus 2 acceleration times delta y. And then because final velocity is 0, we'll again plug in 0 to make our isolation easier. And our delta y is then negative initial velocity squared over 2 times acceleration. And our initial velocity is 9.8 meters per second. We'll just square that, divided by 2 times acceleration, which is negative 9.8 meters per second squared. If we calculate that, the negatives will cancel. 9.8 meters per second squared is going to be 96.04 meters squared per second squared, all over 2 times 9.8 meters per second squared. Seconds will cancel, the meter will cancel, and if we calculate 96.04 divided by 2 times 9.8, that gives you 4.9, and all we're left with our units is meters. So our maximum height that the ball reaches will be 4.9 meters, which is also delta y. And then